Okay, now we're going to continue our comparison of electrostatics with magnetism, and now we want to talk about how can energy be stored in the form of magnetism. But before we do that, let's go back and review what we know about capacitors. So a capacitor is going to be two parallel plates, and then we're going to attach one of those plates to a battery and then go back to the capacitor. So negative charge is going to be coming out of this part of the battery. It's going to flow through the wire, and it's going to start to accumulate on this plate. Now it wants actually to return to the battery, but the problem is that you've got this air gap, or there's some kind of insulator in here that is not allowing it to go through, so that the negative charges have to accumulate on that plate there, and in doing so, in order to conserve electrical charge, positive charge is going to accumulate on the top plate. And so again, notice that it's the same amount of charge because we're conserving electrical charge, but it's separating it. Now if you were to take a positive charge and place it in between those two plates, it would feel a force because it's being attracted to the negative charges and it's being repelled by the positive charges. So that means that there is an electric field inside the capacitor, and the electric field will be going up and down. So we'll say that this is the electric field in there. So that a capacitor stores electric charge. We could also say it stores the electric field, and we could also say it stores electrical energy. And then what you could do is you could use that energy. So if you can disconnect the battery, and now this capacitor is charged up, and then you could connect the capacitor to some other electronic device, and then the charge would drain out of the capacitor, and then that electrical charge can then be used for some purpose, so that the capacitor stores electrical energy. Okay, now let's compare that to magnetism. So you should know that if you were to take a straight wire and then turn it into a loop like this, then it is going to cause a magnetic field to develop in there. So we're going to attach this to a battery the same way that we did before, and so this time it's going to create an electric current in the wire, and then that's going to create a magnetic field that is going to look like this in there. So this thing up here, the capacitor, stores the electric field. The inductor stores the magnetic field. Now, you could, instead of having one loop, what do you think would happen if you had two loops? What would that do to the amount of magnetism inside of the loops? It would increase it, because each of the loops would have its own magnetism, and then the magnetism would combine. So a normal inductor is going to have something like 100 coils in it, and so the inductor is going to store magnetism. It's also going to store electric current in there. It's also going to store electrical energy, and that electrical energy then can be used for something. Now the difference though is that if you take out the battery and you open up the circuit, the inductor loses its magnetism very quickly, as opposed to the capacitor, which can stay charged for a very long time. Now they have their uses. In electronic devices, you have lots of capacitors, and you also have lots of resistors in there. Resistors are going to control the flow of the electricity, and then the capacitors are going to store the electricity. And electronic devices like your calculator and your computer have lots of capacitors and resistors in there. Not so many inductors. Can you figure out why? Inductors are not in electronic devices because inductors make magnetism, and magnetism is bad for electronic components. So that in most electronic devices you don't have a lot of inductors, but you do have these two. So what kind of device would use an inductor? Well, that would be the starter of your car. So when you turn on the starter, it's going to send a pulse of electricity throughout your car, which can be bad because it sends a spike of electricity. So if you run that electricity through an inductor, it will help to smooth out that spike so it doesn't cause as much damage. So that would be one useful purpose for having an inductor in a electronic thing. All right, so be able to tell me what does a capacitor look like and what happens to it when you attach it to a battery, and then the same thing for the inductor. All right, in our next segment we are going to continue our comparison of gravity and electrostatics by talking about the fields that are created by them.